Okay, we are going to do problem number 7. Can somebody read? Sheena, read please for me number 7. Number 7B.
After a few minutes, the water reaches its boiling temperature. The water continues to gain energy from the Bunsen burner. State what happens to the temperature of the water in the beaker.
Okay, can you do this problem if you just read question 7B? Cannot, right? So you have to look at 7A first. What is the situation in 7A? Can somebody describe? I think you have already prepared at home. First you have a beaker with water or ice or gas? Water. And then you have a tripod with the Bunsen burner. And then there's a question, the difference between evaporation and boiling. I have already explained. Now,
This is also
the water reaches boiling point temperature. What is the boiling point of water? Pure water. Pure water. 100. Non-pure water will be higher. Okay. And then the water continues to gain energy from the Bunsen burner. If I ask you from the question number 14 just now, by the way, you haven't gotten from me the question number 14. Is this one, this one, this one, or this one? Which of these 4 is the one that meant?
The first one.
The first one? This one?
No, the one you mentioned.
Ah, this one. It's the vaporization process. Correct? The energy needed is called latent heat of vaporization. Latent heat, I have the formula here. Latent heat of vaporization.
He sent us this thing.
Say again?
He sent us this.
The one, this first one, yes.
No,
You
the
could have
avocado.
the video.
Hmm?
Oh,
Yeah, the first one. Alright, and then let's see number 7
What's the video for?
for you.
Really?
Yeah, you can watch that later on in YouTube or Twitch.
Twitch? You do Twitch?
No. Say what happens to the temperature of the water in the beaker? Increases, decreases, or stay constant?
Constant.
Stay constant. So not decreases, not increases. The other way around. Not decrease, not increase. Okay? The specific latent heat of vaporization of water. Symbol. Energy E or L or M.
Wait.
For the specific latent heat of vaporization. Symbol please. See now? Celine?
I think it's not good.
The symbols. The symbols for this number. What letter should I use for specific latent heat? L. Very good. So L equals to 2.3 10 to 6 joule per kilogram. After the water reaches its boiling point, it takes 12 minutes. So the time is 12 minutes. Delta
T.
uppercase T or lowercase?
Lowercase.
Lowercase. Very good. 12 minutes in second. 12 times 60. Clear?
It's
I don't know.
72 seconds.
Second what? Really?
72 seconds. Only.
But isn't it 720?
720 or 700. Yeah. I forgot to see. Thank you.
12 minutes, 72 seconds.
720. Mass. Stella, mass. 0.0.
0.095.
Yeah. So calculate the average rate of at which the energy is being supplied to the water. So the question is average rate. In German, das ist also die Rate. Rate bedeutet in German, the rate means something divided by time. Always. If I say the rate of the wars happening in the world now, from the Middle Age until now, it's getting more and more and more in a short time. Correct? The rate of the increasing war. Are you with me?
Something divided by something.
Something divided by time. Always. Rate is always something divided by time. The increase of Sam getting bigger. Getting taller, sorry, in German, getting grosser. is the increase of centimeter per time. Now, it means the average rate of energy.
Oh yeah, but the Sami doesn't feel so good.
I don't know. The rate of energy means E divided by
Time.
delta T.
Delta.
And everyone who studied electricity with me knows the energy over time is called
What?
in watt. That's right. The unit is watt. Very good.
Really?
Watt.
Oh.
The unit, he said, the power said watt.
Really?
Did you
Yes,
say what?
the unit is.
What? I said what?
He's not. No, he's not asking what.
He's saying what?
Yes.
He asked
Oh,
what?
and the unit is watt.
Oh.
The unit is watt. And what is the physical quantity in watt?
Oh. What?
Is energy also voltage?
Oh.
Power. Very good. Now,
Can I learn this?
let me answer the question first. So how much energy you need? Uncle Russell, any idea how to calculate the energy now? The delta T is easy, it's already given 720 seconds. Now what about the energy? Latent heat energy. So what? Latent heat. Yes, better. The latent heat. This is the latent heat, right? In our case, it's the latent heat of vaporizations. So what is the formula for the latent heat vaporizations? Yes, clear.
M times C.
Mass times, very good.
C times delta T.
Oh, cannot.
Wait, what?
Why cannot? Why cannot I use the formula with the delta T? Because the process is the one with the flat line. Am I right? The one with the flat line. I hope you don't have any flat line
Formulas for different processes.
in exam or in life.
It's really nice.
What?
I say again, I hope you don't have any flat line
One line, the middle one.
in exam and in real life.
Okay.
So-
This one, right?
Okay, delta T,
This is this.
not.
If it's going up, then you can do this formula. If it's straight,
The other formula.
then you can't do it.
So then I can use this one.
Yeah.
That's right. Only the other one without the delta T because I don't have delta T. So M times L only. Latent heat of
V,
the
vaporization.
vaporizations. Go on, please. So what is the mass? Uncle Russell, what is the mass? 0.095.
0.95.
Holy moly, so heavy.
Latent heat, please.
Unbelievable.
Yes. Sis.
2.3 times 10 to the power 6 joules per kilogram.
Yes.
What?
You're carrying your pen.
What do you mean?
Divide it all by 720. Can you put in? Can you punch your calculator, please?
Punch the calculator, brother.
Punch, please. Yes. Punch your calculator, please. Yes. Answer. Which one? This one?
No.
This one, yeah?
Power 6 or power minus 6?
218,500. Thank you so much. You did your homework. Very good.
But
Yes.
is it spicometry or the transfer?
Das ist 2,3.
Oh,
No,
but
up there.
that's only when you times the top one. You didn't divide it by 720 yet.
Oh, then 720. So what do you get? In what? In what?
What's the formula for power?
Power is always energy over time. The rate of you giving energy or the rate of energy release.
What's the
depending
formula
on
for
the-
energy?
That's a hard question. Even
Yeah.
Joe Thompson needs 34 years in order to come up with the topic energy. Yes?
Can we round the answer up?
Yes? Can you? Please.
303.5-ish. Like round it up.
Thank you. Can you check? Have you punched your calculator?
Can I take
Correct?
Can I take a picture?
Yeah.
280. Just wondered about the
Tomato, how many formulas in general do you have to
What I was
memorize?
asking before.
That's all. Can you go back to the question for this?
Yes.
Watt energy.
One by one, one by one. First question, how many formula do I have? First, MC delta T, M times L. And then you have a formula of power and electricity. Yeah, the metals usually forget easily the formula of the electrical power, which is V times E times T, delta T, fit. Do you still remember the energy you learned? Yeah.
EVQ.
P, power of electricity, electrical energy, power is V I T. Usually Sam also forgets this easily. Yeah, he's not here, but I will appeal to him. Fit. Are you fit?
No.
What's T?
Means are you powerful?
No.
Wait,
That's how I remember the things. Certainly no, but
wasn't VIT equal energy?
V is the Spannung, the voltage, potential difference. I is the current, and T or delta T is the time needed to hit the water, for instance. Are you with me? Yeah. So, sorry. If you have PVI and PVI energy, electricity. Sorry, I made a mistake here. Is V times I times T. Sorry.
No wonder.
If P, VI, if electrical energy, VIT. Field.
Not delta T, right?
Without delta T, yes. You may use delta T, you may use T. Right. Alright, number 7, clear. Any question for number 8?
I have a question.
Yeah.
But in this formula before you used P equals E divided by.
P equals to E divided by T. Yeah, correct. The same. If you, the same thing. You're good in maths, right? If I combine this formula, P is VI. So I put, instead of VI, I put P. So energy is P times T. I change
So
it.
why would you combine them together?
Why not? It's always happening. It always happens in physics and maths. If you combine things, then it becomes a new thing. So then, Stella, the power is E divided by time. Am I right? Same.
Where did the I go? Where did the I go?
Who is right?
Let me do it slowly. Now, this is the general formula of P, electricity, energy, electrical. Now look, what do they have in common? What do they have in common? V and I. So now V and I, can I erase this and then put, instead of V and I, can I put this into it to replace the V and I that was here before previously? So I just write P. Is that okay? Do you understand now? Yeah? Okay.
Wait, so
That's the method in maths, we call it substitutions, correct? Vijaya? Substitutions.
wait, so that what's the name of the new formula then?
No new name. Energy, power, time. No name. Energy, power, time. Alright.
Are those the only formulas we need?
MC delta T, MLV, VIT, and PT.
Can you
And
write
C-
can you write down all the formulas so when you
Wait.
Later.
Until she finish.
Yeah.
Say. Okay, Zelda, she says you can.
can you write down all the formulas we use later?
Can I put in
Yeah.
informal Samlo and send to you in Teams?
Will you
many
remember?
You should remember. You should remind me.
Wait, so it's because there are like 5 formulas.
Wait, but Pinto, is power basically like voltage and time? Or is that not?
Power is basically just anything that you always consider as rate. Every rate is similar to power. Similar. Like the power is just the rate of energy needed. You learn rate every time. You learn rate every time, right? Like, have you heard meter per second?
Yeah.
What is this?
Velocity.
Velocity. Velocity is basically the rate of you travel a distance, because distance over time is exactly velocity. So power is basically the rate of you supply the energy. That's power. Now, in the last administrations of our presidency, there are much more infrastructure built in Indonesia within a short time. in SBA's presidency or SBA administrations, only less structures built in time. So which one is more powerful? Which one is faster? The last administrations.
I have a question.
Yes,
Roughly how much formulas?
I will put in tips. Okay, can we concentrate rather than asking how many formulas with formulas? What if we just practice? Number 8.
I think
Number 8. Shh. Have I done this?
No.
No. Okay.
I
Celine,
think I see
can you read the
answer.
questions?
A student uses an immersion heater to heat some water in a beaker. The water is heated from 20 degrees Celsius to 80 degrees Celsius. The energy supplied to the water is 60.00
Julie.
joules. What is the thermal capacity of the water?
Yeah.
Ignore any key loss.
Okay, who wants to do it on the board? Is it the one with the slope? Is it the line with the slope, or is it the line that is flat? Flat line or slope line?
Slope.
Yes, Bob.
Slope, I think.
And what about the flat line? Bernhard?
I just wanted to do that.
Oh, okay. Tell me. From there, I'm going to do it here, and you
From
tell
here?
me. Yeah, you can say it from there. Yes. So, what do you know?
I did
First, what do you know?
um,
Delta T or delta temperature?
delta temperature.
Delta temperature, how much? 60.
60.
How do you know 60? 80 minus 20. And then
And then the
energy.
Yeah, and
Sometimes
60,
E, sometimes Q is
But in
5.
this case, 60,000 is better.
60,000. Very good.
So
60,000.
then just 60,000 over 60.
Wait, slow. Using formulas, brother. What is the thermal capacity of the water? The process with the slope line. And then you use the formula energy is equals to M times C times delta T.
Why is that necessary?
Delta T.
But we don't know any of them.
Yeah. Wait for a second. First, do we know energy needed?
Yes.
Yes. Do we know the mass of water?
Oh no.
No.
Not
One.
yet. Do we know the C specific heat capacity,
No.
which is us indirectly? Do we know the temperature?
Yes.
Yes. Can I mark first what I know?
Yeah.
This is what I know. This is do not know. This is do not know. This is
No.
known.
You can calculate.
Now, listen carefully. Mass. And this one, small c.
Big C.
So has specific
No,
That's-
heat capacity. But now listen, I already given to you the formula last time. If you combine both of them, the name is...
thermal capacity.
Yes, thank you. 1% remembers. I'm so happy. Thank you. Thank you, dear. So, once again, what is it called? Specific heat capacity. What is it called? Only thermal capacity or heat capacity without specific. So here with the word specific and here without the specific. So the question is capital letter C times delta T, delta temperature. Now meanings C is equals to energy divided by delta temperature. What is the energy now? 60,000 joule.
It's not 1,000.
Temperature difference?
I think I see the answer.
60. So the answer is?
Wait, why did you change it to?
1,000.
It's fine. You can use 60 kilojoules, 60,000 is fine. 60,000 divided by 60?
1,000
1,000 unit please.
joules
Per Celsius.
Kelvin. Why is it Kelvin?
Why is it Kelvin? Why can I use...
Kelvin is the same thing.
Yes, the difference of Celsius and the difference of Kelvin is the same thing, but unit Celsius and unit Kelvin certainly others. So, joule per degree Celsius. Is there any answer? A, B, C?
I
C.
C.
you see.
Yay. Number 9?
So 1,000 was the answer, right?
Yes, sir. Number 9 is so easy. We have done such similar problem.
Where's A?
Number 10. A pollen grain. Oh, I skipped this. It's easy. I want to do this one. with you?
I
Her
thought
total
number
kid
9.
just came in.
Number 9. It was a kid.
Number 9.
There was a kid finding for him.
Oh, yeah. Number 13. You haven't give. You are not given yet the number 13. Can we do it? This is in the book. I say. This question is so important. I say one time. This question is so important. 2 times. I said this question is so important.